All right. Good morning, afternoon, and or evening, depending on when you're watching this. I sincerely hope that you all did well on your test on Friday. So we'll see how that goes, but this video is really just for us to get a head start on force. So this video is going to be really, really light. There's not going to be a lot of math. Hopefully it'll just be, okay, let's learn a little bit something about what force is. And for those of you that are watching this in your study hall on Monday, I will see you shortly. Anyway, so like I said, this next chapter is about force. And the first thing I want to do is talk about what force is. So a force is basically anything that causes, we'll learn that it's anything that causes an acceleration. So causes an acceleration. Another way to think about force is the fact that a force is either a push or a pull. So in general, if you force someone to do something, you kind of have to push them to do it. Well, we're not going to think about force in terms of the colloquial sense. We're going to think about an actual push or pull. So thinking about the types of things that might cause an acceleration, we've already learned that there's acceleration due to gravity. That's something that causes an acceleration. So besides the acceleration due to gravity, we have a force. That's the gravitational force. Besides gravity, just think for a second, what else might cause a push or a pull? Well, we have some specific names for that. One of the names that we have is if you imagine pulling a string. So if you have an object that's hanging, you might have some weight. That weight is due to gravity, but you pulling back on the object is something called tension. There's tension in the string or in the rope. So you actually probably experienced this the most when we were at Sharp Top and we were doing junior versus senior, freshman versus sophomore, and since we're junior senior, I'm going to talk about that. So we had the juniors and the seniors kind of playing tug of rope. And what happens is both of them are pulling on this rope. And with this rope will experience tension both in the junior direction and the senior direction. Another cause of force is related to gravity. So for example, if I have a table, I'll draw it off to the side here, a table, and I have an object on that table, such as a ball, what I'm going to start to do now is something called a free body diagram, which we'll learn more about this coming week, but I just want to introduce the idea. A free body diagram is where we have a force acting on an object, and we draw that using an arrow. So I might label this gravity, and later we'll abbreviate it and actually put a number to it. But in addition to gravity, we're going to have another force actually acting on this ball. So if force causes an acceleration, right now the ball's just sitting on the table. So if gravity is pushing down on the ball, in order for the ball to stay still, the table actually pushes back on the ball. So I know that's a hard concept to understand, but the table is pushing up, it's supporting the ball. So maybe that's one way to look at it. That support is a force. And we call that support force we'll get to names later. But for now I just want to talk about a support force. The reason why I don't quite want to name it yet is because there's a thing called a normal force, and we'll learn that normal means perpendicular to a surface, but not always is gravity and the normal force acting opposite of each other. So for now, I just want to call that the support force. And then we just have generic forces. So if a force is a push or a pull, we might have pushes that aren't necessarily the same everywhere, but we might have a force due to an engine burning fuel. So that fuel being expelled, the gas being expelled out of your exhaust, that's actually causing a force. And that force is called thrust. So airplanes will have this, uh, had a lot of fun when I was back in engineering school drawing lots of free body diagrams. Yet I cannot draw a plane. So please forgive my terrible plane that I'm about to draw. So thrust would be something that would move the plane forward. And you guys know we've talked about how there's a such thing as air resistance. Well, we're going to put a name to that air resistance, and that's called drag. In the airplane situation, again, we have gravity. And something has to hold the plane up. Believe it or not, there's actually a force that does hold the plane up, and it's called lift. So these are just some very specific names. We'll get some other ones, but I just want to introduce to you some names for different types of forces. One of your assignments that I ask is just for you to list some of these names, just so you're familiar. So hopefully this is pretty easy. The next thing that I want to talk about is with the force. Like I said, there's this thing called a free body diagram. Well, what this free body diagram allows us to do is to label all of the forces and figure out what's the overall force on this. So with my poorly drawn plane, I can kind of illustrate this. If I know the thrust and I know the drag, notice how they're acting in opposite directions. If I have more, hopefully I have more thrust than drag, which usually otherwise the plane won't be going anywhere. But if I have more thrust than drag, I can figure out the overall forward force by subtracting the two. Same with gravity and lift. If I know the gravity and the lift, again, hopefully the lift is bigger than gravity, but I can figure out the overall upward force on the plane. So just to get an example, we'll do something simpler than a plane. Imagine that I have a car and I need to hire someone like Yoon or another one of you artists to come in here and draw better things than I can, because I cannot draw. But hopefully it gets the picture across. And because it's a box, I prefer to draw something that looks kind of like a school bus rather than a car. So we have this magic school bus, and say that it has a thrust of 5 newtons. We'll figure out what a newton is, but for right now, just know that it's a unit of force. And say that it has a drag force of 2 newtons. Well, if I want to figure out the overall force, and we have a specific name for the overall force, it's called the net force. All we want to do is find the difference in these two, since they're pulling in opposite directions. One's forward, one's backward. The difference between those two is going to be my overall force. So here, if it's 5 forward and 2 backwards, my net force is going to be 3 newtons. And because the bigger force is going forward, this is 3 newtons forward. And this makes sense, hopefully. If I go back to my junior-senior tug of war example, just one more. Imagine this as being, let's make this a little bit better. We're going to draw some stick figure people. I don't remember, so juniors were gold. I don't know if this yellow is going to show up. Oh, it does. And if the juniors are pulling this way with a force, I'm trying to remember who won. Oh, it's definitely the seniors. Sorry, juniors. But if the juniors are pulling with 11 newtons of force, which is a totally ridiculous number, but we're just putting numbers up here to learn. And I'm pretty sure the seniors were red, white, and blue. So let's get some American. But if they're pulling with a force of, well, we'll start kind of even. Also 11 newtons. Right now, this is at a standstill, and this makes sense. If one person pulls on one end with the same as the other end, then no one's going to go anywhere. The string's not going to go anywhere. So right now, the net force equals 0 newtons. But say another person comes along to the senior and helps pull. And so now instead of 11 newtons, they're pulling with 15 newtons. Well, in this case, the net force would be 4 newtons, and again towards the seniors, just because I have no other good way of describing this. We'll eventually get to a place where we're signing things. So for example, if I had drawn the seniors on the left side of this, I could say instead of the seniors that the net force was going left, I could say that it was negative 4 newtons. But for now, I just want to leave it at this. Your homework is just going to be to answer a couple of questions. Can you give me a couple of examples of types of forces? And can you answer a net force question? So it should be super relaxing. Have a great weekend. If you're listening to this Friday, which I doubt many of you will, good luck to the football team. And if you are listening to this before the cross country, hopefully, I hope you do well on Saturday.